In this example, we will work on how we can enumerate the endpoint, because we know that we have a sort of internal nested implant communications, and we will use this in our network, target network, after compromise as well. And this will also will be followed by a Meterpreter and Metasploit at the same time. And we will follow this type of communications. But before that, before jumping there, we will enumerate the system, because we actually compromise the system, and we know that things are restricted, even though in other steps we worked on persistency, UAC bypass, and etc. Let's assume that we still have low privileges in one of our implants. So we will collect some data on this implant and to understand what's going on in this implant environment. PowerUp is one of those tools developed in PowerShell, and as a part of PowerSploit and PowerShell Empire, it was used by several threat actors. That includes also TA505. So running this with Invocal checks will help us to identify potential configuration weaknesses that could be utilized to elevate privileges. In this system, I did not change anything, so it is simply a brand new system with full patches. So we don't expect anything to identify. Exec PowerShell automation is the command of Patak, and it will run the PowerShell commands through the system management and automation. Now we ask Patak implant to run this. In this case, PowerUp executed some sort of commands that we don't see, but we have seen the output. The output is nothing. The categories are there. If we run this on a privileged process, things may change, and there will be false alerts. For example, this one should be privileged. Let's verify this. Yes, we have a lot of privileges. So let's use the same command against this. This time, this PowerShell script will run with the administrative privileges. So we will see that things may go wrong or right. So simply, some of those items did not work because of the system management automation and argument as well. So some things internally stopped us. We don't know yet, but this is an important information set for us. It simply says that regardless of how we design our weaponization phase, such as designing a network in our point of view, designing staging environment, developing all those tools, designing communication channels and actions on objective stages, as well as lateral movement, real life, the plan won't work well. And it didn't go. So let's go back to our implant, unprivileged implant, and use other information collection tools. Seatbelt is a part of Ghost Pack. So you can use Seatbelt if you clone this repository and if you use some certain parameters given down there. It is developed by Spectros guys, and also several people work on this Ghost Pack, and they contribute some fixes, documentation, or other stuff. And Hamjo is one of the core developers, actually. And this is the tool, and we will run this tool with the basic information. But remember that we quit using PowerShell for a reason. PowerShell is highly restricted and monitored. And before that, before .NET 4.8, .NET was our playground after PowerShell, and there is no MC integration. There is nothing exactly monitoring everything other than ETW, and it was new for EDRs, and we were great. However, things changed. First, we quit using PowerShells. at least using the PowerShell integrated to the system. We started using unmanaged PowerShells. That's another story. We will not discuss it here. Also, we started using .NET assemblies instead, and .NET assemblies helped us well until MC integration in .NET 4.8. Also, event tracing for Windows, ETW, is a common thing for Sysmon and EDRs. So we have some challenge there. Anyway, we will start using these assemblies because COBOL Strike also supports this, and TA505 will use it as well. Seatbelt can accept parameters like that, and it will run some analysis, basic or sometimes complex, and it will give us an output. After the logo of it, OSINFO will show us what we have. High integrity is false. Is local admin true? So we can elevate our privileges using a UAC bypass, which we did already. And we can do more things. But Seatbelt doesn't collect only this information. Let's use this command. And I'm using group user this time and hitting enter. While it is collecting information, we can work on what are the features of Seatbelt and what it will do. It has several different components here, as you see, and it will collect information about the system, user, browsers, and some additional features there as well. As this user is unprivileged, we used the user section, which is group user. So it gives us some information as user. And this will help us to connect remote systems or elevate privileges or collect some data. There is one example here. The system enumeration showed us that this Greedo guy also had this file. We know what it is actually. It is the email I have generated, but we can certainly assume that this is exactly a kind of financial report he was working on for the financial year 2020 or something like that, or maybe 21 for new numbers. And we could get this file before identifying anything or anything else there. We can just look at the logs and we can identify the sensitive or useful objects for us. And also, this is the other folder for DP API master keys. So we have this DP API information here, and it says that you can also use Sharp DP API for master key retrieval. So this is useful for us. Another thing is we have this user, but the user did not use any Firefox. This user has not visited a lot of places. That's why favorites are empty, but the favorites may have additional things. For example, payroll or financial documentations. In our lateral movement stage, we will see that a financial application will show up and we will use it and we will compromise a remote financial application. And this can be discovered using favorites right here. And through this, we can, for example, initiate a Swift transfer or Western Union transfer here. If there will be any map drives, we will see it here. And Office documents, if it will be used for some other documents, we will see it as well. But this time, we only see our malicious file in this Office documents category used in 7 days. So this could be quite useful for us to discover any potential files used by this user, but quite valuable for us. Also, folders identified for users, credentials, and some other data. This one is token information for the internal system and internal user groups, whatever we can reach. Again, we are restricted. And after that, the folder information, local credential data. And there's nothing almost here because this user is new and it did not have anything else useful. I'm going back and listing our implants back again, and I'm using another privileged implant here. But this time, I will use all. Because if you remember, all runs everything. And this time we have privileges. I know it will take time. So let's give that time and see how it will go, whether or not it will fail. If it doesn't fail, we will see a lot of information. Do you see that? They are actually quite useful for us. Having administrative privileges is a good start, but it's not important in most of the red team exercises or trade actor events, because they're after some data, and this user environment is not important. User data is important, or user access. For example, this user may have access to some payroll applications or Swift web applications or some internal servers. So you can use this privilege to compromise the server, or you can actually find some valuable data on this user system, some certain sensitive files, some credentials, or some additional settings. So Seatbelt has dumped almost everything for us. And don't worry about that. The screen is not great, but you will see them in their logs, because Patak also keeps a log file for you. If you go to the Patak service here, the logs show you everything. So whatever log is suitable for that implant. And our implant is MBHH. And this can be read by an editor like that. So the information set here, as I mentioned, that quite useful because we had administrative privileges here. So we can do more. For example, we can add additional users, or we can complete some other stuff here. But instead, we will maybe download a file, upload a file, or we can just start a Meterpreter session with these privileges. And we can see that what we can do with Meterpreter and Metasploit in later stages. In Metasploit section, we know that we need a handler. And I copy and paste all these commands directly. Simply use a handler, just like our weaponization. Set the payload, the IPs are same, everything is same, and create a job for us. And this is jobs. And we can see it. So what we need to do here is simply running a shellcode and seeing whether or not we will receive something in Meterpreter. This may have issues. Remember that Windows Defender is running here, and Meterpreter is also well known and signatured. I started our process injection, and in theory it should work because we didn't receive any alert. Now we have Meterpreter session here, and it is connected well. If we go to the session, we will see the sysinfo, which is our privileged system. Now we have a session, so we are almost there. So what we can do from here is using Metasploit and discovering some other virtual machines in the same network and compromising them through this implant and doing some additional stuff. Remember that Patak can be used as long-term solution. It doesn't need any pinging or beaconing feature. It doesn't need to. When it connects using the WebSocket, it doesn't send any filter information. It works just like interactive socket. So you can keep one of those in that system, such as we implemented in the registry run key, and it can stay there for a long time, and you will not trigger any alert or any event unless you need something. When you need something, you can just fork a Meterpreter just like this. Some .NET applications will also assist you, and those applications will trigger alerts as well. But they are also useful. So I will introduce some of those tools here. But again, .NET environment is also monitored by Windows Defender. So we need to make sure that they are safe to run. In Seatbelt connections, we can also see our Windows Defender information there as well. So we can add excludes, or we can run this in memory, or whatever we use. Our tools are right here actually. Attack service and files. I suggest you to, scenarios and files. So I suggest you to copy some of the tools you want to use right here or somewhere common, and then run them through that way. So simply you can give some parameters. There are some tools, I can introduce them to you. One of those is Sharpcast, is a Mimikatz fork. Another one is SafetyCast, and another one is Better SafetyCast. What they do in common is hiding the activities of Mimikatz, which is dumper, credential dumping solution for a lot of different stuff. That would be LSAS memory or some AD attacks, some Kerberos components, DP API. We have a lot of different things in this Mimikatz. And Benjamin Delphi has developed Mimikatz, and now all of those tools are using Mimikatz or its features underlying. So we can utilize those tools, and Sharpcast is one of those. I can run this, but we don't exactly know what we can do with those systems or implants, right? So this one is the privileged implant, but there are other challenges to run these commands. For example, Sharpcast could accept these parameters, and it is right here as Sharpcast. So if we need to run this, we can use exec sharp assembly and our Sharpcast and the parameter, which is this. So Patek implant can assist you to run almost all those tools as is without any change if they are .NET. If they are PowerShell, it will still work if the tool is not monitored or if tool is not that bad. Probably it will work, just like in our example, it worked for the unprivileged user. And also it runs some commands. So whatever you find on internet or GitHub or in threat intelligence reports, they are useful here to simulate the exercise. I'm giving this command and let's see how it works. It may kill the implant, it may not run, the assembly will fail, or MC will trigger a lot of alerts because logon passwords is simply implemented in Mimikatz, and it needs system privileges, it needs say debug privilege to attach to the LSAS process and dump its memory and extract the passwords and give this output to you, which is not great, and any of those steps will fail. Just like this. This is simple assembly load fail. We haven't triggered an alert. I haven't used file. So let's use file. This is my bad because of the parameters. And we are copying the rest again. So exec sharp assembly, the type is file. So we are giving a file. We need to tell this to attack, otherwise it will complain. And now the file is uploaded. It started running. It runs well. We dumped some credentials. Is there an alert on Windows Defender? Not yet. And some of quite useful information here. Let's wait for it. Any alerts? No. Okay, let's analyze this credential dump. This is Greedo's NTLM and SHA-1 hashes, which are quite useful for NTLM pass to hash. We need to keep this information with us. That is useful. Other one is right here. If we will see some other stuff, that could be here as well. If there is an interactive user or service, we could see the plain text passwords. But at a certain point, we may not see anything. If there will be another user giving the password or another service, we could see even plain text passwords here. But NTLM and SHA-1, they are still useful for us for pass to hash. It is not SHA-1, of course. This one, NTLM, is for us. SHA-1 is the digest. NTLM is the hashed credential that we can resend. It is not a net NTLM. If it will be net NTLM, we will need to crack it. This time, we can just pass it. We need correct privileges, and we can implement this on Metasploit. Let's try this in Metasploit as well, and let's see whether or not it will fail, or it will need something else. So I'm going back to this screen. I'm looking for Mimikatz. So Mimikatz are these modules here, but in Meterpreter, we have different implementations, such as different modules, Kiwi, as well as some other modules that we can utilize here as well. For example, I will load Mimikatz or Kiwi. Let's install Kiwi. Again, Windows Defender is monitoring this process, and I stress on this. This is Meterpreter and Metasploit, and it will fail eventually. Now, what we need to here is learn the commands for Kiwi. For example, credentials all. Can we run this on Metasploit as well? Let's see that. We are not running a system. That's a dangerous thing, because if you use get system, Windows Defender will screen, and we may lose some shells or visibility. We can try this though. This doesn't stop us. Let's use this as get system. Get system gives us the system, and it supports different techniques for it. So we can use token duplication or name pipe impersonation. I'm using the third one in memory, so we can see whether or not it will work, because we have administrative privileges. If we wouldn't have, this Sharpcast will not work. On the other hand, we need system token. So either way, attack or the binary to run should handle this part of it. In Metasploit, everything is manual, so we need to do that. Let's use get system type 3. Let's monitor Windows as well. It says that it failed. Let's use another one. Directly get system. The environment is incorrect. So even though our user is admin, it is not easy to get the system through this way. So we need to implement our own solution. Either way, we need to get system through another way and give it to Meterpreter, or we need to actually use another way to do that. For example, this one. And this get system is here, and it is still there, and getting system and failed to obtain system access. So our privileged account is here. Let's create another Meterpreter and make sure that our process works well. We received another one. Let's interact with the second one, which is here, using get system, and still fails. So we need some personal touch in Metasploit to get this system token that make everything working here. As we can see, this is a trouble for Windows 10 and Office 2019 and Windows Defender environments. Everything is up to date. So we need to play with some of those tools to make them working. That's why most of the trade actors are using Cobalt Strike or some other .NET tools to manage their exercises or campaigns. We use Patak here, and we used Sharpcast to get this done. And we can use some other tools here as well. For example, Sharpsec is also useful. I will give this information briefly. If we are not able to use any Mimikatz tool due to Windows Defender, we can use Sharpsec dump or another dumper as well. And Sharpsec dump is also useful. Sharpsec dump is available here, and Golden Gunsec is the user developing it. Simply, Sharpsec dump is remote dumper. So you don't need to deal with some other stuff. So we can just get the SAM and security, and we can work on it. And this can be done remotely. So we don't need to deal with Mimikatz. Or we can use sharp dump like tools that will dump the memory of LSAS. So we can give this memory to Mimikatz to work on it offline instead of uploading Mimikatz to a remote system, which is what expected by those EDRs and etc. So if you stay away from Mimikatz, you will be out of almost all this trouble. And now we will move on with some Metasploit features.